Solving exponential equations. Property of equality for exponential functions. When two powers with the same positive base or b cannot equal 1 are equal if and only if their exponents are equal. So, for example, if we have 2 to the power of x equals 2 to the power of 5, we can see that both of our bases are the same. So, we can equal both our exponents to each other, which is going to be x equals 5. And that will be a solution. This is only true, okay, where b cannot equals to 1 and only if x equals to y. Our equations in which variable expressions occurs as exponents. If we look at solving example 1, we have the same base, which is what? 3. So we're going to have both our exponents equal each other. X plus 1 equals 5. We're going to subtract 1 from both sides to solve for x, and x equals 4. You have to remember that it has to be the same base. If not, this only works when we have the same base. In B, we have 6. Remember, we have an imaginary 1 where? We have an imaginary 1 in each of our whole numbers. So this is going to be 1 equals 2x minus 3. I am having both of my exponents equal each other. I'm going to add 3 to both sides to group together all my like terms, and this is left with 4 equals 2x divided by 2, x equals 2. In C, we again have the same base. So equal each of our exponents to each other. 3x equals 2x plus 3. Combine your like terms by subtracting 2x from both sides. And 3x minus 2x gives me x equals 3. Solving exponential equations with unlike bases, you first have to rewrite each side of the equation using the same base. In problem A, we have 5 to the power of x equals 125. I need to solve for both of the equation to have both sides have the same base. So we have 5 to the power of x, and I know that 5 to the power of 3 gives me 125. Now I have the same base, and I could equate my x equals 3. In B, I have 4 to the power of x equals 2 to the power of x minus 3. I have a base of 4 and 2. I have unlike bases. But I know that 2 to the power of 2 will give me 4. Use parentheses to separate it. To the power of x equals 2x minus 3. Now remember, that's the power of property. Power of property. So let's equate now where we're going to distribute. We're going to have 2 exponents to the exponents. We're going to multiply. We're going to have 2 to the power of 2x equals 2x minus 3. Equate the exponents, which is 2x equals x minus 3. Solve for x by subtracting x to both sides, and I'm left with x equals negative 3. C, I have 9 to the power of x plus 2 equals 27 to the power of x. No number as a base will give me 27 with any exponents. A lot of students confuse this and say that this is 9 to the power of 3. This is equals to 81, not 27. So do not make that mistake. So in this case, I need to find a common base. And I know that 3 to the power of 2 gives me 9. Power of x plus 2 equals 3 to the power of 3 gives me 27 to the power of x. So I already know that I have the same base. Distribute my 2 to each side, which I'm going to left with 3. And 2 times x gives me 2x. And 2 times 2 gives me plus 4. Equals 3. 3 times x gives me 3x. Now I could equate both of my exponents, which is 2x plus 4 equals 3x. Going to combine my like terms by getting rid of that by the 2x by a negative 2x, which gives me 4 equals x. Now we're going to solve exponential equation when 0 is less than b and b is less than 1. So if you recall from our lessons in 6.1, we recall that we have 1 over a to the power of n is the same as a to the power of negative n. So in other words, when you see a fraction, think of it, it's going to have a negative exponent. So in a, we have half to the power of x equals 4. The first thing you should do is let's flip this half into a negative. So we're going to have 2 to the power of negative 1 over x, correct? The power of our power properties, remember, equals. Now, that 4, I could simplify to 2 to the power of 2, so I could have now the same base. So, I'm going to have 2 over negative 1 times x gives me negative x equals 2 to the power of 2. Equate both of my exponents. I have negative x equals 2. Can I have a negative exponent? So I'm going to have x equals negative 2. I'm dividing both sides by a negative 1. In b, we have 4 to the power of x plus 1 equals 1 over 64. The first thing I'm going to do in this equation is concentrate on this 64. Can I simplify that? Yes. So I'm going to have 4 to the power of x plus 1 equals 1. I know that the exponent will be 4 to the power of 3 gives me 64. Rewrite all this again. We have 4 to the power of x plus 1 equals 4 to the power of negative 3. So all this I did is rewritten, right? Could equate now both of my exponents because I have the same base. So x plus 1 equals negative 3. Get rid of my 1, common term, and x equals negative 4. Now let's solve some practices. If we see here, remember, when we have the same base, that's the first you need to see. You have the same base, we're able to equate automatically our exponents. In this case, our base is 2. So we're going to have 2x equals 6, divide by 2, and we solve that our x equals 3. Number 2, our base is still the same, which is 5. So equate our exponents. 2x equals x plus 1. Combine our like terms by subtracting our x. So I'm left with x equals 1. Then finally, again, I have in number 3, I have the same base. Can equate my exponents, which is 3x plus 5 equals x plus 1. Going to get rid of my like terms. So negative x and negative x, I'm combining. Negative 5 minus 5. I know that this cancels out and this cancels out. I'm left with 2x equals negative 4. Divide by 2. And x gives me negative 2. Now we have unlike bases. In number 4, I'm going to have 4 to the power of x equals 256. I know that in my exponents, if I have 4 to the power of 4, I am going to get 256. Both of my bases are the same, so I'm going to equate my exponents, which x equals 4. Number 5, I'm going to have 9 to the power of 2x equals 3 to the power of x minus 6. I can keep that 3 as my base because I know that 3 to the power of 2 gives me 9 over powered of 2x equals 3. X minus 6. I'm going to simplify, which gives me 3 to the power of 4x equals 3 to the power of x minus 6. I have my same basis, and I could equate my exponents, where I'm left with 4x equals x minus 6. Combine my like terms by subtracting x from both sides, and I'm left with 3x equals negative 6 divided by 3, x equals negative 2. In number 6, I have a 4 and an 8. I know, do not make again the same mistake. The 4 to the power 2 gives you 8. That gives you 16. That's a common error. So I'm going to use 2. 2 to the power 2 gives me 4 to the exponent of 3x equals 2 to the power of 3 gives me 8. Exponent power of x plus 1. Distribute, I'm going to have 2 to the power of 6x equals 2 to the power of 3x plus 3. Both of my bases are same, so I can equate 6x equals 3x plus 3. Going to get rid of my combining my terms, so I'm left with 3x equals 3 divided by 3, x equals 1 for number 6. And finally, we're moving on to number 7. I'm going to automatically have 1 over 3 to the power of x minus 1 equals 27. Here, I'm going to rewrite everything, correct? So I know that this 3 right here, 1 over 3rd, I can have it rewritten as what? 3 to the power of negative 1 over x minus 1, and 27 with the same base. I'm going to have 3 to the power of 3 gives me 27. Distribute, and we're going to have 3 negative x plus 1 equals 3 to the power of 3. I do have the same bases, so I'm going to have negative x plus 1 equals 3. Get rid of my 1, and I'm left with negative x equals 2. I cannot have a negative variable left there, so I'm going to have x equals negative 2.